Good morning, and today I just want to talk about the meaning of integration. Okay, and you have a curve here, and f of x is equal to x square. It's a parabola. It's familiar to you, and I want to find the area under the curve between 0 and 1. Okay, so how do you integrate this x square in the limits 0 to 1? So integral x square, gives you it's x cube by 3. When you substitute the limits there, you get 1 by 3 minus 0 by 3, and that gives you 1 on 3 actually. Like 1 on 3 means 0.33. But if you look at the rectangular pieces here, the strips, if you add all of them, you find that there is some deficiency here, like it is not equal to that. And therefore, see the answer area, what you are getting here, 0.25, doesn't make any sense because, the area under the curve is not completely shown. I'm talking about the left Riemann sums. Okay, so what I should rather do is that I should increase the number of strips here, so that the area under the curve is completely covered. I am increasing the number of strips and reasonably to an extent, and now you should have noticed that my answer is 0.3246. I am getting closer to that. Okay, I repeat this point. The curve we have taken is x square. Okay, you can say y is equal to x square or f of x is equal to x square, and you are determining this f dash x. This integral x square. Integral x square is x cube by 3. Okay, but you have to substitute the limits 0 to 1 because it's a definite integral. And 1 cube by 3 minus 0 cube by 3 gives you 1 on 3. 1 on 3 is approximately 0.33. Okay, bar upon that 3 actually. Like so now, when I take less number of strips, the area I was not getting that 0.33. But when I increase the number of strips, I will decrease the strips and I'll show you. Okay, and now I have fewer strips. The area under the curve is not covered completely. But when I increase the number of strips, and that is going near 0.33, because that is very, very important. That's what we mean by area under curve. Okay, integration is that. Now I am going to write write Riemann sums actually, where the area will be greater than the area under the curve. I will decrease the number of strips now. You understand, it's more than the area under the curve. Okay, the strips have come out, and now what I should do now is, if I increase the number of strips, and that gets closer to 0.33. Now your area is 0.42. That's not the right answer. What you should do now is that the number of strips, if you increase, and now it's covering the area under the curve, and the answer is getting closer to 0.33 actually. Larger the number of strips, closer you are going to 0.33. So whether when you take left Riemann sums, you got an area which is less than 0.33. And when you take right Riemann sums, it is larger than the prescribed area. And in both cases, what you do is that when you increase the number of steps, it is approaching the exact value of that area under the curve. Now, let me change the function, okay, and let me understand how I can do this now. Say I am taking, let us say, a sine curve, okay, I am taking sine x. Okay, and when I take sine x, I don't want this 1, 2, 3, 4 and all that, and I just put it in the radian measure actually, and I want the area under the curve of that sine x between 0 and pi. Okay, and this is my problem now. And let us understand like this. Now we are talking about integral sine x. Integral sine x is minus cos x. Okay, that's fine. When you say minus cos x, between the limits 0 and pi, minus cos pi minus cos 0. Okay, so if you work it out, you get 2 actually, because minus of minus plus cos 0 is 1, and minus of this minus cos pi will also give you that minus of minus 1 will give you plus 1 there. You see that answer is 2 actually. Like you got somewhere around 1.99 here. So whether you take right Riemann sums or left Riemann sums, when you have fewer number of rectangles there to add up, your answer may not be near the exact value, because area under the curve is not, this is not representing that. But when you have larger number of strips actually, and that area under the curve is covered, okay, that's what you should understand, and you are getting closer to 2. So when you change the, let us take another function like just say simple x, f of x is equal to x. When f of x is equal to x, it's a linear function, you got a straight line, y is equal to x. So what is integral x actually? And I will take numbers here, like instead of taking the radian measure, and let me take say between 0 and 3. Okay, and I take less number of strips here to understand whether the area is covered or not. And yeah, this is about right Riemann sums. Now, what is the function? Function is f of x is equal to x. Now, the problem is integral x. Okay, integral x is x square by 2. Fine. But between the limits 0 and 3. So, how do you get this solution actually? Like, and x square by 2. 3 square by 2 minus 0 square by 2. So 3 square by 2 is 9 on 2. 9 on 2 will give you, like 4.5. Like I'm not getting 4.5 now. I'm getting 4.99. So what I would do now is that if I increase the number of strips, and I am getting the area of the curve, area under the curve, because that's a straight line we have taken. And now you see, when I increase the number of steps, I'm getting closer to 4.5. So we can understand the problem like this. We have, x is the function we have considered, and we want integral x, that is x square by 2. But x square by 2 you should take between the limits 0 and 3. So 3 square by 2, that's 9 by 2, 4.5. So that 4.5 I am getting now when I increase the number of strips actually. Like, so if you have fewer number of steps, it does not represent the area under the curve. Okay, so some of these strips is going out of the bound there, and when you increase the number of steps, of course you can understand that represents the area under the curve. Now again I am reducing the number of strips. Now you can see that it is going out of the bound, and let us take the left one actually, the left Riemann sums. See, this area under the curve, it's not representing because there's some gap left actually. So what I would do now is that I am getting 4.19. It is less than 4.5. So when I increase the number of steps, the gaps are covered because we are taking larger number of strips, and now you are getting closer to 4.5. Okay. So that is how we understand the integration of a function with the specific limits when you are given, of course. It's a definite integral, and between 0 and 3, here we have done that. Okay, now I am taking another function. I have x here, and I need x cube actually, like, okay, and I'm taking x cube, and I have to zoom out this one because this is a very big one I'm getting here. Like, so let us understand, if I take it between say 0 and 2. Okay, I can even write my limit here, like, I just can write, say it is 2. Like, so what is this function? We have taken x cube, so we need integral x cube, and integral x cube is x power 4 by 4. That's fine, and between the limits 0 and 2. Okay, so x power 4 by 4 means 2 power 4 by 4 is your solution actually. 2 power 4 by 4 is eventually just 4. Okay, 16 by 4 is 4. But I am not getting this, somewhere 3.88 left Riemann sums. What I again do is that I increase the number of strips so that my answer is getting closer to 4. Okay, that's what you should do. I repeat here, the function taken is x cube. f of x is equal to x cube, and we want to determine the area under the curve, okay, bounded by this x-axis, and integral x cube is x power 4 by 4, and the limits are 0 and 2, that's what I have considered, and 2 power 4 by 4 minus 0 power 4 by 4. 2 power 4 by 4 is 16 by 4, and your answer is 4. So, but you didn't get that. So what did you do? You increase the number of steps. Here I have taken even 120 strips I have taken, and so that I get closer to that 4. And I am taking right Riemann sums now, and the answer is close to 4. But if you decrease the number of strips, you wouldn't be getting that 4. Okay, and you get larger than that because these are right Riemann sums. And so here you find that the sum of these strips, whatever you are considering the rectangular strips of red color, it's more than the area under the curve. So this is how you understand. But when I increase the number of strips, I get closer to that correct value 4. Okay.